The rational root theorem, if you look up here, this is kind of how it's stated in your book. I will simplify this for you, but what it's saying is when you have rational zeros, right? So not nice zeros like 4, -2, 1, like those are what the roots have been that you've gotten so far, and you can see those on a graphing calculator. The rational roots theorem says when you have rational roots like 1/2, 3/4, -5, 6, you can find those, of course, by looking at a graph, but then also by taking p factors divided by q factors, where p factors are your constant number factors and q factors are your leading coefficient factors. Okay, so let me show you a quick example of what all of this means. Okay, when you have a polynomial, let's look at this example right here in your notes. This here, the constant, that is your p. So every polynomial you have, the number without the variable, the constant, is your p. The leading coefficient, so the first number, that's your leading coefficient, that is your q. Okay? So all of the factors can be listed in a combination fraction of p and q. Okay? So what does that mean? If p is 2, all the factors of p are 1 and 2, plus or minus, because double negative is positive. And all the factors of q, which is also 2, is 1 and 2. Okay? So if I do all of the dividing combinations, meaning 1 over 1 is 1, 1 over 2 is 1/2, 2 over 1 is 2, 2 over 2 is 1, which I already have. Okay? The rational root theorem says at least one, so could be more than one. One of these, at least one of these, will be a root of your polynomial. Okay? So why is this theorem important and why do we need to know this? Well, the best way to explain all that is in an example. So let's look at your first example. This is a 4th degree polynomial. So when I have a 4th degree polynomial, how many roots do I need? 4. Okay? So let's graph this to have a look of what this looks like. Okay? I need 4 roots. So 4x to the 4th minus 21x cubed, 21, plus 18x squared plus 19x minus 6 graph. Okay. So if you look here, you see that it's crossing the x-axis in 4 spots, and those are my 4 roots. But the downfall to this graph is there's only one root that I probably know for sure, and that's the 2 right here. And I can double check that with the table, see how 2, y is 0? So 2 is a root, and I know that, okay? And I have 3 more, but those are not nice roots, and I can't find them on the table. I kind of have an idea what they're equal to. For example, this one looks like maybe a 1/4. This one looks like a negative almost 1, right? This one looks like 3, somewhere between 3 and 4, maybe like 3.8, okay? But I can't tell from the graph exactly what it is. In order to get this 4th degree polynomial down to a quadratic, because I can solve any quadratic formula, I need how many roots to take out? 2. Right now, I only have 1. Okay? So let's take that 1 out, and then I can show you with the rational root theorem how to find the other one. So let's do 2, right? Work with what we know. So 4, -21, 18, 19, -6. Right? We should be pros at synthetic division now, right? We've used it a lot. Bring down the 4, multiply, add. 13, thank you. Multiply, add, multiply, add, multiply, is remainder. Okay, so that's a big thing right there, because 0 is remainder means, yep, 2 is a root. We have an answer, but we need 3 more. And if I look back at this graph, there's nothing else I can do synthetic division with. Okay, so that's when I move to PQ. P is my 6, and you can just use 6 because we use plus or minus anyways. Q would be my 4 here because that's my leading coefficient. Okay, so it's always the constant over the leading coefficient. Don't get that messed up. P over Q. Okay, what are all the factors of 6? 1, 2, 3, 6. All the factors of 4 would be 1, 2, 4. Okay. Now I do all of the combinations. So what I like to do is I just start with this first number 1, and I'm going to put 1 over all of these numbers. So 1 over 1 is 1. 1 over 2 is 1/2. 1 over 4 is 1/4. Okay, and then I move to the second number, 2. 2 over 1 is 2. 2 over 2 is 1. I already have it. 2 over 4 is 1/2. I already have that. Okay. Then move to the 3. 3 over 1 is 3. 3 over 2 is 3/2. 3 over 4 is 3/4. Okay, and then I move to the 6. 6 over 1 is 6. 6 over 2 is 3. I already have it. 6 over 4 is 3/2. I already have it. Okay, so this is now what I'm doing. These are all of my options, right? And looking at my graph, what I can do is start crossing some of them off, because looking at the roots on my graph here, I already used 2, so that's gone. And I can also tell from my graph that none of these are going to happen, because it does not cross at 1, -1, 6, -6. I can see that. Otherwise, that would have showed up in my table. Okay, so now I have these left. 1/2, 1/4, 3/2, 3/4. Now, originally, when I was looking at my graph here, this first one right here, that kind of looks like 1/4, right? Okay, this is where the guessing game comes in. You kind of just have to guess out of these options, these 8 numbers, right, both positive and negative, these 8 numbers, which one do you think looks like a root? How would I know for sure? I'm guessing, but how do I prove that it's a root? I do synthetic division, I'll get 0 as remainder. Okay, so let me think. That looks like 1/4, so I want to try 1/4.
Do we have to do it for every single number?
No. Okay, because all I need is one more root to get this down to a quadratic, right? So I just need one of these to work. So let's try 1/4, because that looks like 1/4 to me. So bring down my 4. 4 times 1/4 is 1. Add 12 divided by 4 is -3. Add 11 divided by 4 is a -11/4. And I do not get 0 as remainder. Okay, so good guess, but it doesn't work. Okay, so gotta erase that. That doesn't work. So now I'm going to go back to my graph here and say, okay, that's not 1/4. So what else do I have? This could be maybe -3/4. This could be, no, 3/2 would be 1.5 or -1.5, and I don't have anything there or there. So I can kind of say 3/2 probably won't work. Doesn't look like 1/2. So my second guess looking at this one looks like -3/4. Right? You guys see what I'm doing? You just kind of have to look at your graph and compare it to what your options are. Okay? So my second try to me would be this one and saying it's -3/4. So let's try that. So bring down my first number. 4 divided by 4 is 1. 1 times negative 3 is negative 3. And then I get, wasn't that a 3?
Yeah.
So then negative 16. 16 divided by 4 is 4. 4 times 3 is 12. 4 divided by 4 is 1 times negative 3, and I get 0. That ended up being a root. My second guess was right. Okay, so there's a little bit of guessing when using rational root theorem, but I'm giving you the shortcut of using a graphing calculator. Okay, because now the good news is I now have this fourth degree. If I take out 2 roots, this is a quadratic. So I can write that as a quadratic. And I know how to solve any quadratic either by factoring or quadratic formula. Okay? It's not factorable, so we're going to use quadratic formula. I would take a 4 out because whenever you can make your numbers smaller, it makes it easier, right? If you didn't take a 4 out, you'd still get the same roots, but it just makes it easier. So negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. So 4 plus or minus square root, I have 16 minus 4, which is 12. But I'm not done. We need to simplify that, of course. So 12 is 6 and 2, and 6 is 3 and 2. I can take a 2 out. So I get 4 plus or minus 2 root 3 over 2, which I have to do one more step. And there's my last 2 roots. Okay? So I circle those 2. I go make sure those are circled because 4th degree polynomial means 4 roots, and I have 4 roots, and I circle them to a way to communicate those are my roots. Okay, on homework, tests, quizzes, I would expect something circled or something to communicate to me that you know those are your 4 roots. In the second example, we can see this is a cubic polynomial, so how many roots should there be total? 3. How many do I need to get it down to a quadratic? Just 1. Right? Because if it's a 3rd degree polynomial and I take out 1 root, that gets it to a quadratic which I can solve. Okay? So let's graph it. That's always our first step. Let's take a look at what it looks like. So 2x cubed plus 9, x squared plus 19x plus 15. Graph. Okay? I have 1 root that I can see, and I don't know what that is, right? Maybe negative 1.5 something, I don't know, right? So let's go to our PQ and see what our combinations are. So P is what? 15, very good. Remember your P is always your constant. So P is 15, Q is what? 2, very good. What are all my factors of 15? 1, 3, 5, 15. What are all my factors of 2? 1 and 2, good. Now what are all my combinations, right? What are all my options? So start with the 1 and go over each one. So 1 over 1 is 1. 1 over 2 is 1/2. Then move to the 3. 3 over 1 is 3. 3 over 2 is 3/2. 5 over 1 is 5. 5 over 2 is 5/2. 15 over 1 is 15. 15 over 2 is 15/2. Okay. Now, looking at my graph, since I only have 1 root, and I know it's somewhere between -1 and -2, there's really only one option, right, out of all of those options that I should be picking. Which one is it? -3/2. -3/2 is the only root I have of options up here that's between -1 and -2, right? All the other ones are either too small or too big, right? So 3/2, -3/2 should work. right? If I did all my math correctly, because it's really the only option. So synthetic division, I hope for a 0 as a remainder. Bring down your first term, multiply, -3, add 6. 6 divided by 2 is 3, times -3 is -9. Add 10 divided by 2 is 5, times -3 is -15, right? If fractions are really hard for you, mental math, use your graphing calculator. As long as you're not rounding. Yep. You can use, on these, since it's half, you can use decimals. Yep, but don't round. So this is 2x squared plus 6x plus 10, which is good because now it's a quadratic, and I know how to solve any quadratic. So I would factor out a 2 just to make my numbers smaller. Right? Makes it a little bit easier to solve when you have smaller numbers. So -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is -3 plus or minus square root 9 minus 20 is what? 9 minus 20, -11. Right? So I need one more step because whenever I have a negative underneath the radical, you gotta take an I out. Very good. -3 plus or minus I root 11 over 2. Okay. So I need to make sure you're communicating. Here are 2 roots. I circle that. Don't forget to go back here and say, yep, -3/2 is a root. It's a cubic polynomial, so I have 3 roots. I know I'm done. Right? And that's why on the graph you only saw this 1 root because my other 2 were imaginary. Okay, so 4th degree polynomial, I need how many roots? 4. Very good. If you look at this one, see how it has equal 23x cubed? So the first step I would have to do on this one is get that back over on the other side. So rewriting this, I'd have my 23x cubed, then my squared. Okay. And then, of course, your first step is let's graph it. Right? Let's see what we have. So 3x to the 4th minus 23x cubed plus 19x squared plus 27x plus 6. Okay, so looking at my graph, I can see 3 of them, right? One I kind of know for sure. If you look at this one right here, that's crossing on the 2, and I can prove that by looking at the table, right? It's 2. So I know 2 is going to work for sure, but then I really don't know after that. I really don't know after that what these are going to be, okay? I don't know. Why do I only see 3 roots when I should have 4? My window probably needs to get a little bit bigger. And there I see the 4th one, right? Okay, so let's do 2 because I proved with the table that that was a root. So let's always take out what you know first, right? That helps. Bring down the first term, multiply, add 17, right? Yeah. Multiply, -34, add -15, multiply, add, multiply, and it works. Good. Okay. So to have an idea of where else I'm crossing here, looks like I have 2 of them right here between 0 and -1, and then one way up there between 6 and 7. So PQ, P is what? Q is what?
6 and 3.
P is 6, very good. Q is 3. What are all my factors of 6? 1, 2, 3, 6. All my factors of 3. 1, 3. So then I start doing all the combinations, right? 1 over 1 is 1. 1 over 3 is 1/3. 2 over 1 is 2. 2 over 3 is 2/3. 3 over 1 is 3. 3 over 3 is 1, already have it. 6 over 1 is 6. 6 over 3 is 2, already have it. Okay, so let's cross some things off because looking at my graph, I already used the 2, and I can tell by my graph there that 3, 6, and 1, it's not crossing there. So this is what I'm left with. I'm left with -1/3 or -2/3. And looking at that graph, it can maybe be either one. So it's kind of a guess. What do you want to do? -1/3 or -2/3? And cross our fingers that it works, right? Which one? -2/3? Okay. Let's try -2/3. All right, if I get 0 as a remainder, I know it works. So bring down my 3, multiply -2, add -19. -19/3 times 2 is going to be
This is so sloppy.
-38/3. This one, and this one's not going to work. Once you start getting some fractions, you can tell it's not going to work out. Okay. So what was my other option? 1/3? I mean, you could keep going on that, but once you start getting some crazy fractions, that's usually a sign that that one's not going to work. Good guess, though. It could have been either one. So hopefully this one works, otherwise I'd go back and check my math. 3, -1, -18, 6, -9, thank you, 3, 0, there we go. Okay, see how I don't have any fractions there? So that's my other root. So here I have 2 roots that I know, 2 and -1/3. This is now quadratic, so I know to solve any quadratic. I would factor out a 3, make it a little bit easier. Right, take a 3 from everything, and then do quadratic formula. So -b plus or minus square root b squared minus 4 times a times c all over 2 times a. 6 plus or minus, what's 36 plus 12? 48. Okay. But I'm not done. We need to reduce that. 4 and 12. 12 is 4 and 3. There's 2 4s, take one out. 6 plus or minus 4 root 3 over 2. One more step, right? 3 plus or minus 2 root 3. So 4th degree polynomial, I have 1, 2, 3, 4 roots. So I'm good to go.